Hello, Namaste. Myself Rohini Mirgu talking about physical interpretation of del, that is the del operator in different forms. Learning outcomes. At the end of the video, you will be able to write the equations of gradient, divergence and curl. You will be able to identify the real world applications of gradient, divergence and curl. What is del operator? The del indicates a space variation. It's basically a space variation. Variation of space along the three coordinate axes, that is x, y and z direction. Del operator can operate as well on scalars as well as on vectors. The operator, if at all I want to represent in the equation form, I can represent it like dou by dou x ax bar, that is variation with respect to x along x direction, plus dou by dou y ay bar plus dou by dou z az bar. That is variation along the x, y and z directions. Now first we'll go for gradient. Gradient, the del operator operates on scalars, and in that case the operator is called gradient. Del operates on scalar quantity but results in a vector quantity. If I assume v is some scalar quantity, then del v, which is called as grad v, is equal to dou by dou x of v ax bar plus dou by dou y of v ay bar plus dou by dou z of v into az bar. As you can notice here, dou by dou x ax, dou by dou y ay is nothing but, this part is nothing but, which is shown in black and red, is the del operator. And v is just attached with each term because it's a scalar quantity. This is called as gradient of v. This is equation of gradient of v. Fine, if it is gradient of v, but what actually it is in real world? Let us try to understand its physical interpretation of gradient. Gradient describes the directions of maximum change in other contexts. For example, if we think f as describing some variable, maybe a temperature at a point x comma y, that is at a particular position, then gradient gives the direction. Gradient is giving the direction in which the temperature is increasing most rapidly. It's not mandatorily that increasing, it is increasing or decreasing, that is the change. It is changing more rapidly. So gradient gives the direction in which the variable is changing rapidly. The greatest rate of change for a scalar field with respect to position is represented as a gradient in general. So the meaning of gradient is greatest rate of change of a scalar field with respect to position. Gradient of a scalar field is given known as directional derivative of scalar field, since it is always directed along the normal direction. Now if I want to explain the gradient with the help of a diagram, I can explain like this diagram, where I assume myself that as I am at this dot and I want to move uphill or I want to move downhill. So I am at this present moment at this point. Now I want to move in a certain direction, like to gain the altitude, like upward, or I want to lose the altitude, then I need to move down. So gradient tangent is representing the direction of steepest descent or ascent. So the direction of steepest descent or ascent, which is shown in the red line by the red line here, is called as a gradient. So this is the meaning of gradient in real world. Now let us go to the another operator, which is divergence. The del operates on vectors as well. Previous case we have seen in gradient. Previous case in gradient we have seen that it operates on scalars and results in a vector, but here we look for a del operator which operates on vectors. It operates on vectors by two ways. One is with a dot operator, other is with a cross operator. When the del operator operates with a dot, the operation is called as divergence. As I am operating the del on a vector, let us assume the vector a bar as ax bar, ay bar plus az bar. So let us find out divergence of a bar, that is del dot a bar. So here I have put del in between a dot and this a bar which I have assumed. So there is a dot product between these two. As we know that the ax dot ax is 1, ax dot ay and ax dot az will result 0. So self dot product is giving result. With others it is giving 0. So my answer of del dot a bar is dou ax by dou x plus dou ay by dou y plus dou az by dou z, which is called as divergence of a bar. Fine, this is the equation, but what about its physical significance or interpretation? So to understand the physical interpretation of divergence, consider a water flowing through a large pipe. Let us assume this is a large pipe. To this, two small pipes are attached and water is flowing through this pipe. Now, this small pipes attached, one of that is acting as an inlet through which also water is added to this large pipe. Now, as you can observe here, I have shown with 3 arrows. Now, when the water is input from this end, the water level is increased, like here you can see with the 5 arrows I tried to show. So flow rate is increased. So when the final flow rate is more, you can observe here, this is a final flow rate which is more than initial flow rate, then I can say that divergence is positive. Similarly, there can be negative divergence. Now here I consider that one of the outlet I have opened so that water which is flowing from here is leaking out from this, as I have shown with 3 arrows, and here as the water is leaking out, only 2 arrows I have shown. So when the final flow rate is less than the initial flow rate, then I can say that divergence is negative. So this divergence is negative. So in general I can explain like this: when there is the outward flow less than the inward flow, this is negative divergence. Final flow rate is less than initial flow rate and divergence is negative, which is less than 0. And if the final flow rate and initial flow rate are same, are equal, in that case I can say it is a 0 divergence. If two quantities are same, divergence is 0. And the last case, when I can see here the flow rate at the final flow rate is more than the initial flow rate, divergence is considered positive. So divergence is greater than 0. Now let us go to the last operation, that is curl. The del operator operates on vectors with the two ways like dot and cross that we know. We have seen with the dot, when it operates, it acts, it's a divergence. When it operates with a cross, the operator is called as a curl. So this curl operation that we are going to see, again as it is operating on a vector, let me assume a vector a bar which is ax plus ay bar plus az bar. Now del cross a bar itself is called as curl a bar, which can be given as determinant of ax bar, ay bar, az bar, all are the unit vectors. Then space derivative, dou by dou x, dou by dou y, dou by dou z. Then the magnitudes along the x, y and z direction. So these are the magnitudes, respective magnitudes, along with x, along with y and along with z. These are the magnitudes. The curl is a vector operator that describes the infinitesimal circulation of a vector field in 3D space. Curl at a point in the field is represented by a vector whose length and direction is denoting the magnitude and axis of the maximum circulation. So it is a vector quantity which has magnitude as well as direction. So here I can explain the curl by using this diagram. The curl of a vector field measures the tendency of a vector field to swirl around. Imagine the vector field is represented by the velocity vector. If the vector field swirls around, then when swirls around, in case if this paddle is makes this this to spin, in that case I can see that it is swirling around. Like we stick the paddle wheel into the water, it will tend it to spin. So this is a paddle wheel kept here. When water flows, this will spin, and this spinning itself is called as a curl. Thus we should expect the curl as a vector function. Why? Because it has a magnitude as well as it has a direction. Now I can explain the same thing with this example. Let me assume there is water, and in that water I have put some disc, and I put a mark on the disc, maybe like this, in this direction. When the water flows, the disc will rotate and it will move like this. In the next place, the disc will rotate this way. Again the disc will rotate this way. So what it is doing, it is rotating in anti-clockwise direction. The disc, when it is rotating in anti-clockwise direction, that is indicating the upward direction, and this upward direction is called as direction of curl. And the curl direction is given by the right-handed thumbs rule. It is the direction of rotation, and my thumb will be indicating the direction of curl. Now here I can explain, this is circular rotation, which indicates there is some curl, finite curl, whereas here there is no change, which is zero curl. Here some inward motion also do not indicate it's a curl. Only the circular motion, circular rotation indicates there is a curl. Let us recall the del operator on scalars and on vectors. So the del operator can operate on a scalar and can operate on a vector. When it operates on scalar, the operation is called as gradient, and the result is a vector. But when it operates on a vector, the operation is called divergence when it is operated with a dot, and result is a scalar. And when it operates on a vector with a cross, then the operation is called as curl and also results in a vector. So this is the physical meaning of gradient, divergence and curl, a vector that in the given direction of a maximum rate of change of a quantity, maximum rate of change of a quantity in a particular direction is gradient. Divergence is a scalar magnitude, and it is indicating the sink or source. So if it is sourcing, it is positive divergence. If it is sinking, it is negative divergence. Otherwise, it's a zero divergence. And the vector, when it describes the circular rotation, either right hand circular or left hand circular rotation, it is called as a curl. For right hand rotation, it is right hand clockwise rotation is positive curl, left hand clockwise rotation is negative curl, and if there is no rotation, irrotational, there is zero curl. This is the summary of the physical interpretation of the curl. These are the references used for preparing this video. Thank you.